I will teach you the chapter of hybridization today. So this chapter is very much important with respect to organic chemistry, inorganic chemistry, physical chemistry, because this is the basic of chemistry. How a bond made, how that very big compounds are made. Okay, the whole things can be described by hybridization. Okay, so today we will see what is the hybridization, what is the birth of hybridization, and how can we find the hybridized compound or hybridized orbitals. Okay, this will be our primary aim, and in the last we will see the super tree, how we can find a hybridization of an unknown compound. Okay, that will help you in the competition, in the upcoming competition, that is JEE and NEET, for which you are preparing for. Okay, so now forget about everything, let's take example of CH4, methane. Okay, so as we know that there are 6 electrons, 1s2, 2s2 and 2p2, and the electron in s orbital are paired, but in the electrons in the p orbital are unpaired. There are 2 unpaired electrons in the p orbital. Okay, so according to the valence bond theory, to make bond, what we will do? We will do in the first excited state that this paired electron of s orbital will jump into the vacant orbital of vacant p orbital. Okay, and we will finally see that there are 4 unpaired electrons. Okay, so now after making this, we will take 4 hydrogen atoms, and we know that the electronic configuration of hydrogen atom is 1s1. So there will be 4 hydrogen atom like this. And why? Here is a question, why I take this electron in the backward direction? Because we know in the same direction electron can't make bond, or they can't be paired. Okay, they will feel repulsion, and they will break, and that is why we take the downward electron, which after that will make bond like this. This one s orbital of hydrogen will make bond with the electron of s orbital and the 3p orbital, and we will see that there will be 1 ss overlap, 1 and 3 ssp overlap, and we finally get CH4, methane. According to the PPT, there should be the bond length of ss orbital, overlapped orbital, and the overlapped sv orbital should not be same. But actually what we found, that is very shocking, that all 4 bonds are same. All 4 bonds are same. And here the birth of hybridization. How? Because the hybridization, here if you ask me the definition of hybridization, so I will say you that intermixing of atomic orbitals of same energy, that is very important, same energy, not different energy or higher energy, lower energy, there will be no gap, of the same energy will give new orbitals of exactly same energy. Okay, now if we can't realize what I am saying, now let's take an example of s orbital. This is the s orbital, and there are 1 electron present. If I take the first excited state, okay, so there are 1 electron, and in the p orbital there are 3 unpaired electrons, so this will be the p orbital. Okay, 3p orbital, and they will merge into 4 different orbitals, and that is look like this. Sorry, this will not happen. So this will be the product of intermixing of 1s orbital and 3p orbital, and what we will see that these new hybrid orbitals, or these new intermixing orbitals is named as sp3 orbitals. Okay, so this is the example, or this is the birth, this is the failure of PPT, and this is the birth of hybridization. Okay, so this is the example of hybridization, And after that, what is the main important point of hybridization? That is, we will take the half, empty and full filled orbital into hybridization. Half filled, as we know, that there will be one electron, or in the d, if we take the d orbitals, then there will be a different story. But first of all, we will see like this: empty orbital means there will no electron, and full filled. How can full filled orbitals will take part in hybridization? By giving lone pair. Okay, so also if full filled orbital is there, they will take into hybridization. Now the third point is, that's the most important point, that number of hybrid orbital is equal to number of intermixing orbitals, which means if one s orbital mixed with 3p orbital, they will give 4 sp3 hybrid orbitals. So number of hybrid orbital, what is this? Number of hybrid orbital is 4, and what is the number of intermixing orbital? That is 1 and 3. Okay, so number of hybrid orbitals gives the total number of intermixing orbitals. Okay, now the fourth point is, concept of hybridization is for sigma bond and lone pair. Pi bond will not take into consideration in the hybridization. That is a very big point. If you want to write, and you have to write it, and you have to remember that pi bond will not make any type of impact in hybridization. Okay, the fifth point is, hybrid orbitals are named after parent orbitals. Okay, so what is the meaning of that? That is that one s orbital and 3p orbital gives sp3 orbital. Okay, so the hybrid orbital are named after the intermixing of s orbital and intermixing of 3p orbital. That is the mixing. That will not make that it will is the name of sd3. That will not happen. The name of this hybrid orbital will be sp3. Okay. Now the sixth point is shape of hybrid orbital. The shape, we will know that the shape of s orbital is like this. The shape of p orbital is like this. Okay. Now shape of d orbital is like this. Okay, that is s, p and d. Okay. Now what is the shape of a hybrid orbital? The shape of the hybrid orbital will be like this. That will be the shape of hybrid orbital. This is the large lobe. This is the large lobe. And this is a smaller lobe, and we can ignore it. After that, we can first you remember that this will be the structure of hybrid orbitals, and after that you will definitely see that this can be ignored. Okay, and the seventh point is, the hybrid orient such that repulsion between them is minimum. What is that? There will be more stability. There will be more stability. Okay, so what they will make bond like this, there will be minimum type of repulsion. If that makes a repulsion, so they will not make like this. They will not make bonds like this. They will make like linear compound like this. I want to say that. Now just remember this line. I will give you the example of it. Okay, now let's see the type of hybridization. What is the type, and the hybrid orbitals, of how many hybrid orbitals will be there, we can learn about it. Okay, so if we take one s orbital like this, there will be one unpaired electron, and one p orbital. Okay, there will be one unpaired electron. It will give sp hybrid orbital. Okay, now sp hybrid orbital will example of sp hybrid orbital is BeF2. Okay, and what is the geometry of this? The geometry of BeF2 is like this. Now you can ask me, why Be not make bond with F like this. Absolutely true question. They should make bond like this. Why? And here is the application of hybridization. Okay, so Be have 4 electrons. Be, the electronic configuration of Be is 1s2 and 2s2. Okay, and they have unpaired electron in s orbital. But what we will see that for making the bond, this one electron will transfer into the almost same energy of orbital of p. Okay, they will jump into the vacant p orbital, because we know that there will be 2p0, or there will be a vacant orbital of same energy is present in Be. So this will be the first excited state of beryllium. Okay, and after that, this is the s orbital, this is the p orbital, and it will make of intermixing, and they will give the sp hybrid orbital. Okay, now we know the fluorine have the electronic configuration of the fluorine is a halogen, so the electronic configuration will be like this, 2p5. Now let's clear it so that you can understand the whole thing. Okay, so 1s2 2s2 2p5. So in the p orbital there are one unpaired electron, there is one unpaired electron. Okay, and there are 2 fluorine atoms is present. Okay, so this will make bond with 1 sp, and another fluorine atom will make bond 1 sp hybrid orbital, which is look like this, BeF, BeF. So this will be the sp hybrid orbital, and fluorine give the fluorine will give the p orbital, the electron of p orbital. There also it will react with sp hybrid orbitals. Okay, and what will if we see the structure of this, so it will look like this. I just told you in the last point that hybrid orbital orient such that repulsion between them is minimum, and I have also given that structure of shape of hybrid orbital. So this will be the shape of hybrid orbital, and if we modernized it, so we will see this type of bond will be there if we ignore the small bond. Okay, and the main point is the angle between them will be 180 degree in sp. So this compound will be called linear, and what will be the angle between them? That will be 180 degree. Okay, so this is the main point. So these all are the main point. Okay, we have to make sure that you remember this point, so that it will help in the further study between hybridization. Okay, thank you.